All right, so continuing on with trapezoids, we're going to take a look at number 3. Number 3 says find the altitude, which is the height, for the isosceles trapezoid. All right, so we're looking for this dimension there, the height or the altitude. All right, so first thing we know is we have an isosceles trapezoid. All right, if it's isosceles, we're going to get some characteristics that are kind of almost hidden in here. All right, first thing, the top and bottom are parallel, so those two distances have to be the same, all right, between the 12 and the 18 length side. So if that's the case, when we look at these triangles, we have a hypotenuse leg for a right triangle as a congruence rule, which allows us to get this. We could also use the fact that the base angles are the same, and then look at it from an angle side angle perspective. Sorry, from an angle side perspective. All right, but either way, the left and the right side are congruent. So we know this length and this length have to be the same. All right, the top is 12, the bottom's 18. All right, we know the interior piece here is 12, that leaves me 6. So I get a 3 over here on each side. All right, so a 3 on each side. Now, at that point, I'm going to use a right triangle on the left side. I have 3 squared plus h squared equals 5 squared. 9 plus h squared equals 25. H squared equals 16. And then take the square root of both sides, and I get h equals 4. All right, and we're only concerned about the positive answer here because it is a geometric feature of this. All right, so the altitude is 4. No units were listed, so we don't need to worry about units there. All right, if I go over to 4, 4 says find the perimeter of this shape. All right, so the perimeter, first thing I'm going to do is I'm going to carry this height or altitude over to the other side. All right, I'm going to carry that 14 down to the bottom. All right, and again, that's just from here to here. So what I need to find is I need to find this piece x and this piece y. All right, so I'm going to do Pythagorean theorem twice here. So I've got x squared plus 8 squared equals 17 squared. That's going to give me x. And then over here, I'm going to do 8 squared plus y squared equals 10. All right, so if I run through that, all right, on this side I've got 64 plus y squared equals 100. So y squared equals 36 when I subtract, and that gives me a y equals 6. So I know that piece is 6. All right, over here, 17 squared is going to give me a 289. All right, so I have x squared plus 64 equals 289. Subtract the 64 off both sides, and I get x squared equals 225. All right, now 225, if I take the square root of that, is going to give me 15. So I get x equals 15 by taking the square root of both sides. All right, so that tells me that piece is 15. Now, that makes perimeter a pretty quick problem because we have all the pieces. So we're going to walk around the outside of this. I'm going to start at the 14 on the top, plus, moving to the right, the 10, plus the 6 we found, plus the 14 we dropped down from the top, plus the 15 we found, all right, plus the 17, and that takes me all the way around, so I don't add any more. And when I've got that, I need to do just a little bit of arithmetic here. I've got 14 plus 10 plus 6 plus 14 plus 15 plus 17, and that gives us 76. All right, so this would have a perimeter of 76 units. And again, if units aren't given, we don't need to add them into the problem. All right, so number 5 says QS is 12x. All right, so the full length of that is 12x. All right, find x and RT. All right, in isosceles trapezoid QRST. All right, so first thing I noticed is it told me it's an isosceles trapezoid. So I have these two sides congruent, and those two very clearly from the picture of the two parallel sides. So I'm going to start by setting 5x plus 2 equal to its congruent side, the 6x minus 5. All right, add the 5 over, I get 7. Subtract the 5x over, I get x. So x is 7. Now, once I have that 7, I can bring it back in, all right, because we know QS equals 12 times X, which would be 12 times 70, which would be 84. All right, so if QS is 84, we know that the diagonals in an isosceles trapezoid are congruent, so we get 84 for that side as well. All right, and that's our link there. So again, there we're banking on the fact that in an isosceles trapezoid, diagonals are congruent. Isosceles trapezoid, diagonals are congruent. All right, looking at the final one of these problems before we get to our coordinate problem. All right, this one says if QS is 19, all right, so it's 19 all the way along that diagonal. All right, TU is 3x plus 5, and UR is 2x minus 1. All right, find x and UR in isosceles trapezoid QRST. All right, so we would have been stuck if they wouldn't have given us the word isosceles. But as soon as we hear isosceles trapezoid, we want to think diagonals are congruent. So I'm going to take the diagonal we know is 19 and set that equal to the sum of the two pieces that form the other diagonal, the 3x plus 5 and the 2x minus 1. So I've got 19 equals 5x plus 4. I'm going to add the 4 over, so that's a 23 equals 5x, and we'll divide both sides by 5. All right, that is 23/5 for x. All right, and then whenever I get an answer like that that's different from the rest of the ones I've seen on the page, I always like to just double check myself to make sure I didn't make a silly mistake or miscopy. So 3x plus 5, 3x plus 5, 3x plus 5, those match. 2x minus 1, got a 2x minus 1, and a 2x minus 1. All right, and that added together would be RT, all right, which is this diagonal. Then QS, they told me, was 19, so that's good. 3x plus 2x is 5x. 5 minus 1 is 4. Subtract the 4, so I did have a little mistake there. All right, and if I subtract the 4 from both sides, sorry about that. All right, then we have 15 equals 5x, and x equals 3. All right, so we have an x value of 3. Then they specifically ask you for UR. All right, and UR was defined as 2x minus 1. So UR equals 2 times something minus 1. We just found that something was 3, so that's 6 minus 1, or 5. All right, and that's for UR. So UR here is a 5. All right, so that takes us through those problems. So we're going to call this video, and then I'll be back with one more video segment to work through a coordinate problem so we can see that last type of question that could get asked.